Howdy everybody, it's me Danielle again, and if you're wondering why my hair is pink now, it's because October is Breast Cancer Awareness Month. But anyway, to continue on, I want to do another equilibrium problem, or problem set, that has been a problem for a lot of students in Dr. Hill's Chemistry 1C class. So, we're going to be focusing on pressure in this case, and the effects of pressure on different systems, and the way that their equilibriums will shift in order to relieve that stress. So this is going back to Le Chatelier's principle. For those of you who are still a little bit confused on what Le Chatelier's principle is, then you should check out my previous video on the effects of heat on systems. Just to recap though, Le Chatelier's principle states that a system that is put under a stress will move in either the right or left direction, in other words, toward the products or toward the reactants, in order to relieve that stress. So here, we're looking at the effects of pressure, and the problem asks us, which way or in what direction will the following system shift after the indicated stress is applied? So, this first question, we have 2 moles of gas, A and B, in equilibrium with 3 moles of gas, 2 moles of C, and 1 mole of D. We want to know what's going to happen, which way will this equilibrium shift, right or left, when we increase the pressure. So if you're a visual learner, we have this box filled with A, B, 2 C's, and a D. And we're going to increase the pressure. So if we're increasing pressure, that means the box is going to get smaller. So this is our change in pressure. We're going to make this box really small, and we want to know what the composition of the final box is. Is it going to have more A and B, or is it going to have more C and D? So which way is it going to shift? The secret to solving this problem has a lot to do with just understanding a basic principle that has to do with pressure. So when you increase the pressure of a system, you're going to have more collisions between those atoms and molecules. And when you have more collisions, that means that you're going to have buildup of pressure. And Le Chatelier's principle says that if we put a system under some stress, or if we introduce some stress to a system, then that system is going to relieve that stress so that it can return to equilibrium. In this case, we're increasing pressure, so we want to relieve that pressure. And the way that we can relieve that pressure is by decreasing the number of moles in the overall system. So we want to decrease the number of moles. And if we look here, we have 2 moles of gas on this side, and we have 3 moles of gas on the product side. So if we're increasing the pressure, would we want to have more moles of gas or less moles of gas? The answer is that we want to have less moles of gas if we're increasing pressure, because we want to relieve that increase in pressure. So we're going to shift to the left, toward the reactants. So the answer for this one is shift left. So in this box, you're going to have more A and B and less C and D. And if that makes sense, then you should be able to do these 2 videos on your own. So if you want, pause this video and try to complete them on your own and come back and I'll go over the answer. And we're back. Hello guys. So we're going to tackle these 2 problems. And these are a little bit trickier, and I did this on purpose to prove a point. When we talk about the effects of pressure, as you may understand from, Chem 1A, pressure is only really going to affect gases. Solids and liquids are incompressible for the most part, so they're not going to be affected by changes in pressure. In other words, we can completely ignore any liquids or solids in these problems when we're talking specifically about pressure. So here we have 2 gases, A and B, in equilibrium with 2 moles of C, which is a solid, and 1 mole of D, which is a gas. So what you can do if you want, since we're talking about pressure, is just completely ignore that C, okay? And that might freak you out. It's okay. It's not going to affect the end result of this answer. And in this case, we're increasing the pressure once again. So since we have 2 moles of gas on the reactant side and only 1 mole of gas on the product side, and we're increasing the pressure, then we will shift to the right, shift right, toward the products in order to relieve that stress. So we're increasing the pressure and we're relieving that stress by shifting to the side that has less moles of gas. Okay, so if you got that one right, then good job. If you didn't, then go back and check to see where your misunderstanding is. Okay, and here we have a very similar problem, except now our exception is on another side. You'll see what I'm talking about. So we have 1 mole of gas, which is A, 2 moles of B, which is a liquid, 2 moles of C, which is a gas on the products. So we have this new equilibrium, but the same rules apply. And in this case, we're decreasing the pressure, which means that our box is getting bigger. So in this case, we have a liquid, which, like I said, cannot be compressed for the most part. So we could just completely ignore that. It's not going to affect the answer to this problem, because we're talking about pressure. So, since we're talking about pressure and pressure is decreasing, this is the opposite mentality of what we normally have. Let's still do what we've been doing, write out the number of moles of gas on each side. 1 mole gas on the reactant side and 2 moles of gas on the products. And since we're decreasing pressure, we want to relieve that stress by, in this case, increasing pressure by shifting to the side that has more moles. So we're going to be shifting to the right in this case. And that's it. I hope that you guys have a better understanding of these pressure problems, and I hope that you see the patterns that are involved in them. And good luck with chemistry. Have fun.